Hi, this is video 1 on random variables. This is chapter 18. So in this video, we're talking about what random variables are. Let's say you can attach a real number to some outcome in a sample space, right? And then you have a function that's defined on that sample space, and that function that relates that outcome to a real number is called a random variable, right? So that's the definition, right? That's stated here. Okay, it's usually denoted by an uppercase letter, an X or a Y. A random variable is a function by definition, it's a function from the sample space of an experiment to a set of real numbers, right? Let's look at an example to understand what this means. Okay, suppose that a coin is tossed twice so that the sample space is something like this. And let X represent the number of heads. So this is my random variable. This is the measurable property that I'm interested in, right? So as you can see in this table, each sample point or outcome can be associated with a real number. For example, because that's the way I defined my random variable, that it represents the number of heads. Okay, so one outcome could be that both are heads, so X is 2. One outcome could be first heads, second tails, then X is 1. Similarly, the third outcome could be one tails and one heads, so X is 1. And another outcome could be that we have both tails, right? So the outcome is 0. So as you can see that each outcome is mapped to a real number. And this real number representation is my random variable. Okay, so this was a simple example. Let's look at a more complex one in which I have this experiment of tossing 3 coins, and I have 2 random variables defined on this experiment. So the first one is number of heads, that's represented by X, and the second one is Y, that means all matching tosses. So the way I'm defining Y is that it either takes on a value of 1 or 0 depending on a yes or no. Yes, all tosses match. No, all tosses do not match. Okay, so uh, a standard way of representing random variables for any experiment is to go and tabulate all the outcomes and then map to the real numbers. So that's what we're going to do for this experiment. So my sample space S is all of these outcomes. So obviously I have H, 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 and then let me quickly write down all the possible outcomes. T, H, H, T and T, T, H, H, T, H, T, 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 H, right? And then, sorry, T, T, and T, right? So now the way I've defined my random variables X and Y, I can map each of these to a value that's a real number. So for example here, this is going to be 3, right? Because all heads, 2 heads, 2 heads, 1 head, 2 heads, 1 head, 1 head, 0 heads, right? Similarly, I can define my random variable Y in terms of each of these outcomes. So all matching tosses, yes, no, 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 and yes. Okay, and by the way, the probability of each of these we are assuming is 1/8. Why? Because each of them are equally likely and there are 8 of them, right? So as you can see that each of my random variables X and Y have attached a real number or a value to each outcome, right? So directly these random variables do not have anything to do with probability as such, but we can define events using a random variable. And then using those events, we can find outcome probabilities, right? For example, I can say, what is X equals to, right? What is this particular event? Now this means when the number of heads is exactly equal to 2, which is this, this, and this, right? Or I can actually write this down, which is H, H, T, like all of these events, H, T, H, and T, H, H. Right? Similarly, I can figure out what is X greater than equal to 2, right? All possible outcomes that have heads at least 2 or more, right? So all of these plus one more, which is H, H, and H, so 4 of them, right? So using this information, we can actually derive probability values. So let's look at some examples. Probability using discrete random variables. I'll come to this discrete part in a short while. Why? Because we are essentially dealing with discrete random variables in this course, although there are continuous random variables as well. Okay, so going back to how to calculate probability. So let's say I'm interested in calculating the probability of this event, right? At x equals 2. Now, from the previous slide, I know that there are exactly 3 such outcomes, right? And the probability of each of these outcomes is 1/8, right? So I'm going to actually what I'm doing here is I'm adding 1/8 plus 1/8 plus 1/8, which is 3/8. Why? Because going back to the previous slide, you can see that the outcome probability of each of these is actually 1/8. And this is true for, like, we'll see what I'm talking about. Okay, what happens if I'm interested in calculating the probability of x greater than equal to 2? So in this case, remember 4 of these, so I'll add 1/8, 1/8, 1/8, and 1/8, which is 4 over 8, which is 1 over 2. Okay, how about if I'm interested in the probability of y equals 1? So y is 1 for, let me just like write down the events first. So y is 1 when we have h, h, and h, and t, t, and t, right? So I can say that the probability y equals 1 is actually 2 over 8 or 1/4. Okay, how about the probability of this event x greater than equal to 2 and so this is an and y equals 1. What are all these events? Right, when x is greater than equal to 2, so all the cases when we have 2 or more heads, and also when y is 1. So if you think about all these, there is just one such scenario when y is 1 and like when they overlap. That's what and means, right? When both hold or they overlap, like both of them. So the probability of this event or probability of x greater than equal to 2 and y exactly equals 1 will be 1/8. Okay, so that's how we can determine probabilities of discrete random variables. In the next video, I'll begin talking about how random variables, why this random variable is a discrete random variable, and how can we compute the probability distribution functions.